So, the important chapter is atoms. So, atoms, the moment the atoms means which is your favorite elements in a periodic table? Hydrogen. Yours is hydrogen. Yours? Potassium. Why potassium? Why hydrogen? Any specificity? So, universal universal solvent. Okay, yours? Potassium. Huh? Any justification? So, these are the some of the way we have plenty of how many elements are there in periodic table now? 216. 16. So, the periodic table if we take all the things. So, what specialty about in the specialty about things, I am taking the two important thing I am taking it. One is what is the least in periodic table? So, physics only. So, you have to know chemistry also. Huh? Least yeah, hydrogen you can take. Least one I will taking as hydrogen. Highest weight molecular weight. Huh? Uranium. No, uranium, not uranium. Uranium is in between that. Still highest is there. Okay, we can take uranium itself. We don't have periodic table. We can take a periodic uranium itself. So, in this series, so something. So what is the electronic configuration of hydrogen? 1? 1s1. Yeah, correct. 1s1. Why are you blinking? 1s1. But what is the uranium configuration of electronic configuration of uranium? 238. 235. 235. So 235. So how many electronic configuration it will have? It will have 1s2. It has various s orbital electron configuration, p orbital electronic configuration, d orbital electronic configuration, f orbital electronic configuration. So in this series itself, how many will be? 1s1, 2s2, 2p6, 3s2, 3p6. So what is the maximum orbital of s will occupy? 2. Why are you blinking like this? S orbital, how many electrons it will occupy? 2. P orbital? 6. D orbital? 8. Huh? 8. D orbital? 2, 6, 10. F orbital? 14. 14. 4 into 2, 14. So, S orbital is spherical, but how many orbital P will occupy? How many orbital P will occupy? 6. So, it is Px, Py, Pz. What is Px, Py, Pz? Huh? Px is the orbital in the x axis, Py is orbital in the y axis, Pz is orbital in the z axis. So, now comes permutation combination. Now, how many orbital d orbital will occupy? 10. So, this 10, so how can I divide this orbital? d xy, d yz, d xz. So, 3 orbitals came. Now, d x square minus y square minus d z square. D z square. So, if I take this orbital, what is this? So, what is the orbital? That means I am going to hydrogen. For hydrogen, no problem, because hydrogen has only one electron. So, but if I go for a higher element, means it has how many electrons? 235 based on the atomic weight. Then based on the atomic number. Okay, its atomic number is 235. That means how many electron it possesses? 90. No, okay, fine. 235. Okay, let us assume it is 235. So how can you split into 235? 1s2, 2s2, 3s2, 3p6, 2p6. So like that, if you split this means you have to split into various orbital, which is, so you have to become based on various orbital you have to split. So how many orbitals it has? It has many orbitals. lot of s orbital, s orbital, p orbital, d orbital, f orbital. So various orbitals split the electron is split into various orbital. For uranium, for hydrogen, one orbital. So that means the electrons, so I am having to now here, this one is nucleus, this one is so this one is nucleus, this one is electron, we have various orbitals. So this one, so I am going for uranium itself, uranium 235, uranium 235. So this one is what? Electron only, I know, that is why written as electron. What it, where it is located?
Negatively charged. First orbital.
Yeah, first orbital. Electron is located in the first orbital. This is the electron located in the
Nth orbital.
not nth orbital, last orbital. Nth orbital, okay, you can take it as nth orbital, but you can take it as a last orbital. So I am having now, I am not taking consider inner, which is electron in the inner orbitals. All the orbitals, the electron which is in the inner orbital, I am not considering. I don't want that. Just I am taking two electron. One is in the innermost orbital, which is the first innermost orbital or first orbital, outermost orbital or the last orbital. Two electrons I am taking. So which will have the attraction. So the now here nucleus. So nucleus electron are having attraction and electron having attraction to here, which will have the most attractive. Yeah, which is electron in the inner orbital. Inner orbital will have the highest attraction to the nucleus. This one is a very outermost. Outermost. This is similar to that planet what we have seen. Earth, sun with respect to Mercury, Venus, Earth, to the outermost orbital Pluto. So the distance between the Pluto and sun far away, but Earth near to it. So what is the surface temperature will be of Earth with respect to Pluto? Just surface average temperature. Average temperature of Earth. What is average temperature of Earth? Not 30. Why are you blinking? So you say some value, I will tell the correct one.
90 degree.
Huh? 30 or 40. What you told? 90. 90 is not. If 90 is there, what will happen? What is the boiling point of water? 100. If the average temperature of Earth is 90 means, what will happen to the water present in the Earth? It will be in the vapor state, it will not in the liquid state. So average temperatures around the world is 40 degree. In India is 30 degree, but in abroad is 20 degree. In Sahara it is 50 degree. So overall, if you take average temperature is 40. But I am going to Pluto. What is the average temperature of the Pluto will be now? Average temperature of the Pluto. Minus? Not minus 30, it will be more nearly very low temperature. So it will be minus 100, not even minus 100, more than minus 200. Okay, we will keep averagely minus 100. So here it is 30, here it is minus 100. In minus 100, what will happen to the water temperature? Will be in the it will be in the high state. So the temperature will decide, the distance will decide the thing. Same thing I am coming here. The electron affinity towards nucleus, electron affinity towards the nucleus. So this will have the attractive force. So I will have into F1, F2, something. No, F0 you can put, F0, Fn. So F1, F0 is greater than?
Fn.
Yeah. Okay. So simply if I take this nucleus is made up of proton plus neutron. Okay. So this nucleus attraction towards electrons. So if you take these two, if you take uranium 235, so something attractive, so F0 is greater than Fn. So you take all the pictures now, and this force is given by 1 by 4 pi epsilon 0 charge of nucleus.
Positive plus negative.
No, it's a 0. So Z is
Configuration. Atomic number.
R is radius. Okay. Geiger-Marsden experiment. This one is Geiger beam of alpha particle. Okay. So I am Geiger-Marsden experiment. He performed a simple experiment. What he took? He took the source of alpha particle. Okay. He took some elements which will emit the alpha particle and pass it to the beam of thin gold foil. So then what it is doing? Thin gold foil means what? Thin gold film. Something both are same. Foil and film, everything same. Thin gold film. Gold. Yeah. Yeah. Then how it looks? Gold. Thin gold film. Simple. So for a film, if you take, then he performed it. Then what he observed? Then the screen was here. Okay, it was dictated in the screen, which is a zinc sulfide screen. It was dictated in the screen. So what is my question? If the screen was kept with some angle from the this is a straight source and film, and here it is, the screen is kept here. Instead of keeping screen here, you can keep a screen here also, and you can keep screen also. Here, keeping here and here are same. Okay. Only option is first option is, second option is here.
Okay, sir.
So you understand my question?
Why has kept the
Something here, and keeping here, let us assume x, y, z. So x equal to z, x position and y, z both are same, but he kept both are same. Okay, so you forget about x. Okay, y and z. So if you able to see, if he kept in here also y, and here also so y he kept in the, instead of y he kept in the z.
Because the alpha particle traveled in the straight line, sir. Here இது வந்து எப்படி சொல்றது?
No, instead of keeping here, he has kept it, this is y position, this is z position. Y he kept in the z position. You understand my question now? At least now.
Yes.
Okay. So instead of y, it means he is kept in the y also. He kept in the both the position. Okay. X, y, z. Okay. X also he kept, y also he kept, z also he kept. But he just point out only y position. Why? Because it unable to show some scattering angle. It didn't pass to the straightly. That means it is a particle of any particle of heavy will try to deflect the surface. Some particle is there. So it has a mass m. So alpha particle has mass m.
The alpha particle is so lighter, sir.
So no, not so lighter or so heavy. Some mass. It has some mass. You understand the question now? First you understand the question. If you understand the question only, you will understand this answer. This is the answer. You understand the question or not?
Sir.
So the alpha particle is having some mass m. That means alpha has some alpha particle. Alpha particle has some mass m. Beta particle that also mass m. So that also will show the scattering. Then gamma, gamma. You understand question now? See, alpha particle, this is experiment with respect to alpha particle. Okay. Then if you perform, in case let us assume I am performing for alpha, beta, gamma. Let us assume we are performing the experiment. You forgot about that fellow, that Ganger. Okay. What he showed that beam of alpha particle passing towards various scattering angle. Okay. Various scattering angle. So that means it has a mass m. Let us assume for beta particle, in case if we are performing, what will be the mass? Will have some mass or mass equal to 0?
Have some mass.
It will have some mass. How?
Others scatter out.
If he has a mass only, it will show the scattering power, otherwise it will not show the scattering power. Okay? Then I am going for gamma. So what it will show scattering or not? Gamma.
Gamma also has some mass.
No, gamma will not show.
0.
Gamma. So in this experiment, if you perform for alpha and beta, it will show the scattering power, same scattering power. But if you show for gamma, it will not show for scattering power because it does not have the mass m. So that's why you perform this experiment. Okay, so that's why. So the number of scattering power, number of scattering particle dictated, scattering angle decreases. Finish? The taken diagram, everything.
Yes.
F is a force of attraction is a force of attraction is equal to centripetal force. 8 pi epsilon r. No, this is electron orbit. Total energy in the electron orbit. Total energy of the electron. Total energy of the electron in the nth orbit. Total energy of the electron in the nth orbit. We will go for hydrogen itself. You go for NEET for uranium. Simple, one electron is there that rotates the nucleus. Okay, simple. So we go for very simple one. Electron is there that rotates the nucleus. So this that's the electron. What is the force that acts between nucleus and electron now? Force acts between nucleus and electron. Force of attraction, and its counteraction is centripetal force, which is Fc. So mv square by r by 1 by 4 epsilon 0 e square by r square. So if I take r is equal to e square is equal to 4 pi epsilon 0 mv square. So in that so total energy is equal to potential energy, kinetic energy is equal to half mv square. So in this mv square, if I take this v square here and r here, what will I will get? E square divided by 4 pi epsilon 0 m r. So v square is equal to e square divided by 4 pi epsilon 0 m r. So this m and this m will cancel. So I will get e square by 4 epsilon 0 E0 r. So 4 into 2, 8. That's all. Then potential energy is equal to E square minus 4 pi epsilon 0 r. So total energy is equal to this and this. So which is E minus E square 8 pi 4 pi epsilon 0 r. Okay, you taken this. Take it now. Atomic spectra. When an atomic gas is excited at low pressure, when atomic gas is excited at low pressure by passing an electric current through it, when an atomic gas excited at low pressure by passing an electric current through it, emitted radiation has a spectrum that contains the specific wavelength only. That has the specific wavelength only. That has the specific wavelength. That has the specific wavelength. Okay, this specific wavelength is called the this spectrum is called the emission line spectrum. This spectrum is called the emission line spectrum. So this is a various spectrum: Lyman, Balmer, Paschen, Brackett, Puffin. So for ground level, most ground level is Lyman, second level is Balmer, third level is Paschen, fourth level is Brackett, fifth level is Puffin. R is Rutherford constant, Rutherford constant. Okay, Bose radius. First one is Bose radius. Okay, the Bose proposed that electrons will revolve around the nucleus. Electrons are revolve around the nucleus in a stable orbit. In a stable orbit. Hence, this is the stable state. Okay. First one. So En is equal to minus 13.6 by n square eV. En is equal to minus 13.6 by n square eV. So the energy of this orbital is energy is electron volt. So 13.6. 13.6 is a constant value. N square. What is n square? N square is the location of the orbit. If it is n is equal to 1, it is n is equal to 1. What you will substitute? You will get 1 square. So minus 13.6 electron volt. If n is equal to 2, 2 square 4. So 13 divided by 4 approximately it will be around 3 point something, 3.2 something electron volt. So for first orbit it will be minus 13.6 electron volt. So that means the energy affinity of, that means what? What do you mean by that?
Which one, sir?
Let us assume n is equal to 1. Okay. So if I substitute n is equal to 1, what I will get now? 13 minus 13.6 electron volt. What do you mean by that?
Orbital 1 ku adu varum.
What is that energy?
The energy for orbital 1 is minus 13.6.
Okay, that's what is, energy of orbital 1 is 13.6. Okay, you keep as just put as 13.6 itself, not minus. Okay, minus is different. Okay, 13.6 electron volt. What is meant by 13.6 electron volt? That is my question.
The energy of the orbital.
What is that energy? That only I am asking. Energy of orbital is 13.6. What is that energy?
Binding energy.
Binding type of binding energy. Binding energy means the force of attraction between the nucleus and the electron. So now we go for what we yesterday, photoelectric effect. Okay, I am taking this nucleus, electron, nucleus, phi. Okay, now I am ready passing the nu. Nu is frequency. This one is phi, which is binding between electron and nucleus. Okay, so the electron when will the electron travel? When will the electron will travel? If the
Frequency is greater.
if frequency is greater than the binding energy. What is binding energy here for hydrogen? For hydrogen it is 1. I don't want second also. Don't go for second. 2, 3, 4, 5, 6. I don't want anything. Just one simple hydrogen is sufficient for me. So for hydrogen, what I will substitute here? 1. So if I substitute here for hydrogen, binding energy is now minus 13.6 electron volt. So but here the binding energy, say for example hydrogen is there. Okay, hydrogen is there. Binding energy, what is the binding energy now?
Minus 13.6.
Okay, 13.6 electron volt. So the now the electron should travel. So what is the frequency that I have to supply now?
More than
13.6 electron volt. If I supply more than 13.6 electron volt, what will happen? The frequency, it will break the binding energy. Then the electron will travel for the hydrogen. So like this, it will vary. All the elements will vary. That's all. Here is binding energy. This one is energy. En. So, do you take this that I already gave no? What is the point I gave for first point? So, total energy is En is equal to, you take this point, you take this equation. No, not 1, 2 and 3, only 1.
Yes, sir.
You taken, okay? And this electron in an atom could revolve in a stable orbit. The electron in an atom, that revolve in a stable orbit, without the emission of the radiation. So the radiation is not emitted means the electron is not
Rejected.
electron is not ejected. That means the electron is stable around the nucleus. Okay, this is the first point. Second point is the electron will revolves around the nucleus only it has a definite angular momentum. Okay, so L is equal to n by nh 2 pi. N is the integral value. Integral means definite value means 1, 2, 3, 4, 5 up to n, and h is the Planck's constant. N is the integral value, nh by 2 pi. nh by 2 pi, n is the definite value means 1, 2, 3, 4. 1, 2, 3, 4 up to n, up to infinity. Now up to n, up to infinity you can put. N is equal to 1, 2, 3, 4 up to infinity. I am passing some radiation. Okay, the electron is jumped from the inner level to the outer level, which is, so inner level is the inner level is the innermost, where it is falling it is the outer is the final value. What is the final value means what? Final means where the electron reaches. The where electron reaches, that's the final, and where the electron is staying, that is the initial. So I can put this one as a EI, this one as a EF, okay. Orbital I can put as a OI, orbital OI, OF. Energy that is needed is EI with this electron, the electrons having the affinity of attraction is energy EI, okay. When it falls here, now the electrons energy with attraction towards the nucleus is EF. So total energy, total nu is equal to EI minus EF. You taken this H nu is equal to EI minus EF. Did you understand this concept?
Yes, sir.
Okay. This is the electron, same, this is jumping, just only one electron we are taking it, okay. This electron, this one is the initial electron, initial state, final state. The energy that is having attraction is EI. Then now once it passes the radiation, it will move from one orbital to another orbital. So then that orbital is called EF, final value. So the final value, so EI is equal to EI minus EF. So it's not EI minus EF, EF minus EI. EI value is greater. Why? Greater, which will have high attraction, the force of attraction. EI will have the force of attraction. This EI will have force, that's why EI minus EF. So H nu is equal to ENI minus ENF. H nu IF is equal to ME divided by E8 E0 square H square NF minus NI. So NF is the final value in final orbital, level of orbital of final and level of initial. Level of orbital. So Ln is equal to NH by, you taken this?
No, sir.
You take this.
First you explain.
Okay. Ln is equal to NH by 2 pi. Just I already explained, N is a definite value. Definite value. So which is N is equal to 1, 2, 3, 4, 5. Then 2 pi N is equal to N lambda. So 2 pi N is equal to NH by MVN, which is, if you cross multiply this angular momentum, you will get 2 pi N is equal to NH by lambda. Yeah, it is 2 pi N. What is the N here?
Definite value.
R. No, Rn. R. What is R here? Radius. Radius of the electron to the nucleus is equal to NH by MVN. MVN. What is the V? Velocity of the electron. Okay. So if you correlate both the things, you will get MVN Rn is equal to NH by 2 pi. So that is the radius of the electron is equal to, from the radius electron we can calculate. So you can calculate the Vn. Vn is the velocity of the electron. So the velocity of electron is equal to NH 2 pi divided by Rn MV. Vn. No, if I take Vn, what will I get? Vn is equal to NH 2 pi into Mrn. That's all. This one the Dirichlet's radius of the equation. No, you can put Dirichlet's divided it, but you can find the velocity of the electron. Vn. You can find the velocity of the electron. Small and big N. No, limitation of Bohr's proposals. Bohr's atom model. Limitation of Bohr's atom model. What is limitation? Limitation means what? Disadvantage. That is Bohr's cannot. First one is limitation of Bohr's model. So the first one is the Bohr's model can propose only to the hydrogen atom, not to any other higher atoms other than hydrogen. Bohr's model is only applicable only to the hydrogen atom, not to any other hydrogen atom. Example, you can tell. What is example? Bohr's model can only applicable to only to the hydrogen atom, not to any other not to any other model, not to any other metal, not to any other atom, not to any other atom. So example, you can tell.
Boron, carbon.
No, simple thing you can take. Helium. That is, it applicable only to hydrogen. Other than hydrogen, it cannot be any other, means helium. It cannot applicable. So it cannot be applicable to helium. So it cannot be applicable to helium. So if you can't apply to helium means, then what will happen to the boron and carbon and all? It's not applicable to any other things except hydrogen. It can't applicable to any other thing. Okay. So next it produced in boron models. boron proposed for hydrogen. In hydrogen model, it proposed in hydrogen model.
Boron?
No, just in hydrogen model. The hydrogen model that he proposed only for in the hydrogen model that he proposed, it is applicable only to the frequency. Frequency is nu, intensity is I. So it predicted only the frequency. So he can't predicted the intensity. So it predicted only the frequency, not the intensity. இதுவா ஏன் இருக்கட்டும் இல்லை உங்களுக்கு அந்த
சார்ஜ் கம்மியாகிடும்.
ஓ சார்ஜ்
சார்ஜ் கம்மியாகிடும்.
ஓகே